So here, if you observe this example, what is there here? When kids are in the learning phase, they use it to learn by going through some books or by watching some movies or through TVs or through mobiles, etc., or by showing some images to them. So this kind of learning they are habituated. So this is the learning with the, this is what learning with the labels. This is the process of learning with the labels. What is the label here? So if you consider this example, what is the data and what is the label? So here this is the data, whereas the name label activity is converted. This is the label. So when the kids are in the learning phase or in the training phase, when the kids are in the training phase, they use it to learn data along with the label. They use it to learn the data along with the label. Coming to the second phase, which is nothing but the testing phase, because there are two phases in the classification: training phase and testing phase. So coming to the test phase, here this is the testing phase. Suppose if you take the children to the zoo, he is able to identify whenever he saw an elephant or whenever he saw a lion, he saw a tiger, he is able to identify that animal. Identify or not? He is able to identify. How he can able to identify? Because of based on his trained experience within the classroom or within the home, within the room, based on his trained experience, he can able to identify that particular animal. So he just recollect all the things what he learned previously, and he compares that if at all the animal is up to particular so and so height, and if at all it is having some trunk, if at all it is in so and so color, if at all it is having tail this much of length, like this, if at all it is half teeth, then it is the elephant. Like that, he can able to recollect all the things whenever all the things from his learning phase or training phase, and those experience can be used by him to identify the what to identify the unlabeled animal in the zoo, because whenever you took him into the zoo, you no need to tell that this is, you no need to label that element, he can able to label it. So just observe the process of labeling. So what happened in training phase? Hope my voice is audible. So what happened in training phase? Here the kid or student is nothing but the classifier in our example. Here the student is nothing but classifier in our example. So what happened in training phase? We are providing data along with the labels or along with the classes. Data along with the labels we are providing in the training phase, and we are giving some training. That means the classifier is trained initially. The classifier is trained initially on the training data, which includes data along with the label. So the classifier is trained initially on the training data, and after that, in the testing phase, the data used for training is completely different from the data used for testing. So here artificial images, whereas here real animals. So we are using some data, some unlabeled data, which is not used in the training phase. So in the testing phase, we are using some unlabeled data, and the classifier classifies the data. That means the classifier can able to label the data based on what? Based on the training experience. So what is meant by the classification process? Classification in the sense classifying the data tuple to the appropriate class label based on the training experience in the training phase. So classifying the data tuple to the appropriate class label in the testing phase by using the knowledge gained in the training phase, by using the learned knowledge in the training phase. This is the process of classification. So how accurate your classifier is? How accurate your classifier is? So how can you validate or how can you check the accuracy? So if you consider the same example, if at all there are five animals, you show the kid to the kid in the zoo. if you show the five animals, one is elephant, lion, tiger, like this. Suppose some elephant is there, and tiger, lion, some monkey, and some what horse is there. And these are the five animals you showed to the kid, and he can able to identify the elephant as elephant, and he can able to identify tiger as, for example, cat. He can able to identify lion as lion. He can able to identify monkey as okay, some monkey, and he can able to identify horse as donkey. So what happened here? He can able to properly classify some animals properly, whereas in case of some animals he may get confused. He misclassifies some animals. So here is the need for the classification efficiency. We need to validate the process of classification with some measures or metrics. So we can validate that this is the correct classification, this is the correct classification, this is the correct classification, whereas these two are the wrong classification. So based on the number of correct classification, we can estimate the efficiency of the classification process. Or in our case, we can estimate the efficiency of the classifier based on the number of correct classification. So this all comes under the there are some methods for estimating the efficiency of the classifier like this. So what is the broadly what is the process of classification? So classification is the process of classifying the unknown tuple to appropriate class in the testing phase based on some training experience gained in the training phase. Then what is meant by prediction? So we are using the terms classification and prediction because our topic is classification. Our chapter name is, unit name is classification and prediction. So this is the classification. Then what is meant by prediction? So here, if the labels are categorical, then that process is called classification. If the labels are not categorical, if we are having some numerical labels here, for the data set we have chosen, if you are having some numerical labels, then that process comes under prediction. So if you consider this data set, here all the labels are categorical labels. So here, whatever the process, use it to assign some labels to the unknown tuples or unknown observations. That process is called classification in this example. And in this example also, that process is called classification. But whereas if you consider some other data sets, so if you consider this, here the class labels are numerical values. Whereas for this data set also, here the class labels are numerical values. So if at all the target attribute, is numerical, then the process of predicting the unknown element is called prediction. Whereas if the target attribute is categorical, like this, if the target attribute is, this is the target attribute, right? This is the categorical attribute. So that process is called the process of identifying the unknown label. The process of classifying the observation into the unknown label is called classification. So only entire process is similar, theoretically similar, but only the difference is the label which we have to identify is a categorical label, then the process of identifying the label to the unknown observation is referred as a classification, whereas if it is a numerical label, then the process of identifying the label to the unknown observation is prediction. Please unmute somebody, make some noise in the class. I think now we are clear with the terms classification and prediction.
2 into Karan, 5 minutes time.
Number 23. Okay. So what is the process of classification and prediction? Can anybody from the class, what is the process of classification and prediction in your own words? So if you can able to tell here, you can able to attempt it in your exams easily. What is the process? What is the process of classification and prediction, or what is meant by classification? Anyone you can tell. What is the process of classification? What is meant by classification? What you get from this example? What you get from this example? Anyone? Number one, Ceci.
Ma'am,
What is meant by classification? What you get?
actually we can clearly know, or we can clearly separate different types of data, ma'am, by using labels.
By assigning some labels,
We can
classify
easily
the
understand.
we can classify the data
Yes, ma'am.
based on what? How many phases we are having in classification? Okay. I think this example is clear to all of you, right? So what we are doing, we are having two phases in classification. One is training phase and second one is testing phase. So in training phase, we are making the classifier to learn something on the training data. We are making the classifier to learn something on the training data. Whereas in the testing phase, we are testing the efficiency of the classifier by assigning some new data to classify this. So actually what happened in this image, we are training the kid. We are trying the kid, or we are make him to learn about the animals. We are making to learn about different kinds of animals actually. Here, this is in the training phase. Whereas in case of in the testing phase, we are giving some new data which he don't see previously, because previously he's seen only the images, artificial images of animals, diagrams of animals, etc. We don't see real animals in the training phase. Whereas in the testing phase, we bring him to the zoo, and he can able to identify. Most of the children can able to identify, even though he first time directly uh, look into that particular animal. Even though it is the first time, he can able to identify it. Why? Because he has some past experience with the training phase. Like that, here also we are having two phases for the classifier, or two classification phases. So I'm just briefing from the beginning onwards. So here, look at the slide. Classification and prediction are two major types of prediction problems. So we are predicting something, predicting the label for the unknown observation, predicting the label for the unknown observation. So there are two forms of data analysis. Those can be used to extract models. So what is meant by model here? So when you make the kid to train on, when you make the kid to learn on some data, that learning process is defined as a construction of a model. So whenever the classifier is in the learning phase, then automatically a model is generated with the learned knowledge. A model is generated with the learned knowledge. So there are two forms of the data analysis. Those can be used to extract models describing important data classes or to predict the future data trends. So such analysis can help to provide us with better understanding of data at large. The classification predicts categorical labels. We observe this difference particularly. Classification predicts the categorical labels, whereas prediction models continuous valued functions. So whereas classification, the label should be categorical, whereas in case of prediction, the label should be a continuous value or a numerical value. So here is the data set. We already know that what we call the columns of a table are represented as attributes, whereas the rows of a table are treated as an observation or data point or example. Right? And this is called as multi-class iris data set. What is meant by multi-class here? Why multi-class? What is meant by multi-class here? It reflects what? Multi-class.
More than two classes.
More than two classes. If the data set consisting of more than two classes, here is one class, and set of one class, Arjanika is one class. If the data set consisting of more than two classes, then that data set is referred as a multi-class data set. And if at all it's consisting of only two classes, here the classes are S and no. So if the data set consisting of only two classes, then it is referred as binary class. And coming to the actual process of classification, this is somewhat in depth. So classification is the process of identifying the category or class label, which is of course which is discrete valued. Why? Because if at all it is not discrete valued, if at all it is continuous, that process is referred as prediction, not classification. So obviously, when you are talking about classification, the label should be a discrete value. The value of the label is discrete. That means categorical. So it is the process of identifying the category or class label of the new observation to which it belongs to. Observation in the sense, uh, that means a row of a table. Observation or tuple or example, whatever. Where a classifier or a model is constructed to predict a categorical label. So what is the actual process? Here the data set is initially partitioned into two parts, training part and testing part. So for the training part and testing part. So for the training part, generally 70% of the data is made for the that means assigned for the training phase, whereas 30% of the data is allocated for the testing phase in general. In general, 70% of the data is assigned for the training phase, whereas 30% of the data is assigned for the testing phase. There is no commonality, there is no common tuples between the training and testing data. They should be different. They should be completely different. And one more thing, the training data should include labels, whereas the testing data should not include the labeling. In the last class, I told the same, right? So if at all you divide the data set like this is for training and this is for testing. This is suppose this 70% of the data is allocated for training, whereas only 30% of the data is allocated for testing. In the training phase, we can include the label. In the training phase, we can include the class label. Whereas in case of testing phase, we should not include the class label. Because the task is to determine the class label. The task is to identify the class label. That's why we need to remove it first. We need to remove it. So actually what happened initially? Initially the data set is divided into training and testing, because from the beginning of the class itself, I'm repeatedly telling the same thing. Start from that example, kid example, I'm repeatedly telling the same thing. Because understanding this concept is very important to go for the next topic. So here, the data set is divided into major part of the data set is go for the training set, whereas minor part of the data is divided as the testing set. And this training data is selected to train the classifier in the first phase. There are two phases in the classifier construction, right? This is helped in the phase 1. This is helped in phase 2. In the phase 1, this training data is used to train the classifier, used to learn the classifier and thereby constructing the model. So by learning on the training data, a model is constructed. What is the process of learning? How the classifier is going to learn? It learns like this. If the outlook is some reality, if temperature is hot, if humidity is high, if windy is false, then the label is no. Again, it go for the second observation. It again reads the second observation. So if outlook is rainy, if temperature is hot, if humidity is high, if windy is true, then the label is no. Like that, the classifier goes for each and every observation, and based on what condition, the label. So based on what aspects of the attributes, what aspects of the predictor attribute, the label is decided. So if at all so and so values are there for the attribute, the label is like this. So everything it needs to trained on the training data. Like student is trained on the textbook, as I said in this particular example. So how he able to try? So if we consider this observation, each and everything is an observation. How he able to train? How he able to learn this? If at all, it consisting of one more animal in its stomach. If at all it is of so and so color, if at all it is of so and so height, this is a kangaroo. Like that, based on its characteristics, everything is a characteristic. So if at all it is green in color, if at all some cover is there, or its body, if at all it only having four legs like this, so then it is a something a tortoise like that. So based on the characteristics of the class, based on the class characteristics, here the class is yes and no. Here there are only two classes. Yes is one class and no is one class. So based on the particular class characteristics, what are all the characteristics of the class? So by observing all the characteristics present in the characteristics are also called as the attributes. By observing all the predictor attributes present in the training set, the classifier is able to learn something, able to gain some knowledge. So that overall thing generates a model. So once model is constructed, the model is tested using the test data. The model is tested using the test data. So how your objective exam is going to evaluate, going to conduct, or how your internals are going to be conducted. They only provide some questions. They don't provide any answers. Answer in the sense that is the label. Whereas whereas in classroom, they provided questions and answers. That means we taught something. We taught something in the sense we are providing some information about the topic. So here I am telling that this is the process of classification and this is the process of prediction. Whereas exam, I'm just asking about what is the process of classification. I don't provide the answer there. That you need to identify. That is the process of actually classification. Identifying the label for the unknown observation. So based on what? Based on the training experience which you already gain in the training phase. Training phase in the sense your classroom experience. You have something in your classroom. You have gained something. With that something, you can generate a model. So that model can be used at your exam to answer the question. So this is like an exam. The second phase is like an exam to the classifier. So without providing any labels, we won't provide any class labels, and we are testing by using the test data. So if at all the classifier labels accurately, then we can select it as a best classifier. Otherwise, we can enhance the performance of the classifier. So if at all you gain good marks, so that is okay. If at all you are not gaining good marks, you can enhance your performance. You can rethink about yourself, what to do, at what topics I need to improve like that. The same concept. So here classifier is the process of identifying the category or class label of the new observation to which it belongs to, where a classifier or a model is constructed to predict the categorical labels. So here initially training phase is there, training data is there, right? So training data is submitted to the classifier. So here some learning process is actually going on. So after this learning is completed, after learning from the training data is completed, a classification model is constructed. So once the model is constructed, this model takes the test data as input. This model takes the test data as input and produces some labels for the test data and produces some labels for the test data. And further, these labels are verified. How to verify these, whether the resulted labels from the classifier are correct or not? How to check? How to cross check that? How to cross check whether the output of the classifier is correct or not? Is there any way to check? I think all of you getting my point. So here what I am saying is, if you consider a data set, we are hiding some part of the label and we are submitting the corresponding observations to the constructed model. We are submitting the corresponding observations to the constructed model, and that model needs to classify each observation. All these four are the unknown observations for the model. Why unknown? Because we are removing the class label. Because we are removing the class label, and that model is nothing but a classifier. That model should able to classify each observation. For example, the model classifies this as some. There are three classes, right? This is classified as class 1, and this is classified as class 2, and this is again class 3, and this is again class 1. There are some classification result you can get. So what I am telling is how to cross check whether the result we obtain, whether the labels generated by the classifier are accurate or not. In which way we can check the accuracy of the classifier? Is there anything to compare? Whether the obtained labels are correct or not, how to check? Is there any way? Every time, no need to ask, no need to call the number. It is not good. Is there any way to check?
టెస్ట్ చేసిన వచ్చిన అవుట్పుట్ క్లాసిఫికేషన్ మోడల్తో కంపేర్ చేసినప్పుడు సేమ్ వస్తే అది కరెక్ట్ మ్యామ్, ఫాల్స్ వస్తే
కంపేర్ చేయడం దేని దేనితో కంపేర్ చేయాలి? వచ్చిన అవుట్పుట్ ని, అంటే వచ్చిన అవుట్పుట్ అంటే ఇది, రైట్?
వచ్చిన మ్యామ్
వచ్చిన
కలెక్షన్ ఆఫ్
అవుట్పుట్
డేటా ఉంటుంది కదా,
అంటే ఇదేనా ఇక్కడ మనం ఏవైతే రిమూవ్ చేసామో ఇదేనా మీరు చెప్పేది? అంతేనా? అంటే మనం ఇక్కడ దేని
మ్యామ్ అంటే మనం తీసుకున్న డేటా కలెక్షన్ కి వచ్చిన టెస్ట్ చేయగా వచ్చిన అవుట్పుట్స్ ఉంటాయి కదా మ్యామ్, అవి రెండుటిని వెరిఫై చేసి క్రాస్ చెక్ చేసినప్పుడు రెండు సేమ్ వస్తే అప్పుడు మనం టెస్టింగ్ అవుట్పుట్ కరెక్ట్ మ్యామ్, లేదంటే తప్పు.
100% is a right answer. Simple thing. So I'm able to know that you are following the class, and I'm very happy for this. So we already have the original labels, right? We are removing the original labels and we're testing the classifier. We're testing the model. What is the purpose of testing? So before going to implement the same in the real time environment, if you generate something, you need to test that. You need to test the accuracy. In which way it is efficient, you need to test that. Every software module has a testing phase, right? So similarly here also, we need to test it first. Within the same environment, you need to test it first. If at all it is successful at this stage, you can later implement the same model, later apply the same model to classify a real data, to classify the real data. So here also what we are doing, we are just removing the labels, and we are applying the model to classify these unknown four observations, and we are getting some classes like this, and we are comparing these classes with the existing classes. We are already know that. We just remove that and we just save it in another folder. So we can able to compare that. So here the class 1 is, suppose this is versicolor. This class 1 we are getting is versicolor, but here the class 1 is virginica. So the first classification, out of four observations, the first observation leads to a wrong result. Suppose here the second class we are getting is versicolor. Here also we are having versicolor. So the second observation is classified correctly. Like this, we need to make some we need to make some process to know the efficiency of the classifier. So based on that, if at all it is efficient enough, you can use directly to classify the unknown example in the real time. If at all it is not efficient enough, then again you need to enhance the process of learning. You need to enhance the learning process. There are so many methods for that. Okay, like this. So here is an example for that. So for doing that, we are having several classifiers. KNN, K nearest neighbor is one of that. Support vector, mission, decision tree, navigation, artificial neural network, random forest. And in my PhD, in my research, I have used this KNN. So all are good. All are equally good actually, but it depends upon the problem. We need to select which classifier we need to use. like that. So I am very, very familiar with this KML because I have used this in my work. So coming to the same thing here, a classification is a two-step process. We already know about all the things, but I'm just going through this to get again the brief thing. So here we already know that classification is a two-step process. The first one is learning or training phase, and the second one is the testing phase. I'm just again repeating the same thing here. Just observe carefully. I'm just going to read out all the things which we have already explained, which we have already learned just now. So here, in the learning phase, where a classification algorithm, wait for it. So in the learning phase, a classification algorithm builds the classifier by learning from a training set made up of database tuples and their associated class labels. This is already known. Training set includes the data values and along with the labels. So it can be viewed as a learning of the mapping function y is equal to f of x. It looks like that actually. It looks like that. We need to calculate y from f of x. So that can predict the associated class label y of a given tuple x. So a tuple x is represented by an n-dimensional attribute vector, whereas the tuple is represented as a n-dimensional attribute vector. So if at all you consider the iris data set, x1 indicates the sepal length, x2 indicates the sepal width, next petal length, petal width. All these are the attributes. So those can be represented as an n-dimensional vector for a given tuple. So the class label attribute is discrete valued or categorical and unordered. We already know that. If at all it is a classification, the class label should be a discrete value. So the individual tuples making up the training set are referred as the training tuples and are randomly sampled from the data set. So how to generate the training set, training data? Actually, for your understanding, I told that 70% of the data is taken as training data and 30% is taken as testing data. But generally, those sampling of those partitioning of the 70 to 30% actually partitioning of the 70 to 30% should be done randomly, should be taken randomly, random sampling. If at all you're having a bucket of balls and I want to take 10 balls, so if at all I take randomly 10 balls from that bucket, that is a random sampling. Otherwise, use it to pick the balls based on the color or based on the size or based on the uh, position they have arranged in the bucket, or I only pick up the top the balls in the topmost position of the bucket. Like that, if at all there is any constraint, that is not a random sampling. If at all roughly randomly, I put my hand in that bucket and I take out some group of 10 balls from that bucket, that is a random sampling. Here also we are having different codes are there in R and Python. We are having different direct codes for making the random sampling from the data set. So that process can be used here to make the random sampling of 70% of the data from the data set like that. So there we are. So the individual tuples making up the training set are referred as training tuples and are randomly sampled from the data set. So if at all, if you perform the random sampling and if you pick the 70% of the tuple and you have developed a model and you have tested on the test data and you are getting the efficiency of the classifier is not getting up to the mark, if at all the classifier is efficiency is not up to the mark, what we can do further is you can again take a random sampling. You can again backtrack to the original process. So you can again backtrack to the original process here. This is the original process. So here randomly you have sampled, you have selected 70% of the tuples as the training set. So if at all, if you go with this training and testing phases, if at all the accuracy of the classifier is not up to the mark, again you can backtrack to the previous steps, and here again you can take the random sampling. Because if you take random sampling for the first time, some so and so tuples are retrieved. Whenever you have done the same thing for the second time, the same tuples may not be retrieved. So some other tuples randomly, 70% of some other tuples randomly may retrieve. So based on that also, the training may changes. The model construction process may change. The constructed model may change. Also, the efficiency of the classifier may change. This is one of the steps to enhance the efficiency of the classifier. If at all we are not getting the good efficiency, you can backtrack and you can change the sampling seed. That means in the Python or in R, you can have a code to which can take some seed value. Some seed value you need to enter there, some 23, 50, whatever. So based on that seed, you can able to it can able to generate some random number. So based on that number, you can able to take some random observation. So if at all you are not getting the good accuracy, you can go back and you can change the seed. That means the which simultaneously changes the training set. In both the cases, 70% of the data is selected as the training set. There is no doubt in it. But what happens? We are changing the tuples we have selected, like this. So here, in the context of classification, the data tuples can be referred as samples. So these already we have discussed, right? The data tuples are referred as samples, examples, observations, and some more names are there here. Instances, data points, objects. So all these are the different names used to refer a data tuple or a, if you consider the table, row of a table. So coming to the supervised learning. If class labels of the training set are provided, then this step is also known as supervised learning. Otherwise, it comes under unsupervised learning. And these are also two famous buzzwords used in classification process. If the during the process of classification, if the class label is provided, then it is called as supervised learning. If the class label is not provided in the dataset itself, in the training phase, what we know till now, we have to provide the class label. That only we know till now. If at all the class label is provided, that process is called classification, and it is also called supervised learning. Supervised in the sense, what is meant by a supervisor? Supervisor in the sense guide. In your project, somebody may ask you what is your who is your supervisor for your project. That means who is your project guide. Guide in the sense who provides you something. So if at all the classifier is the model is constructed based on some labels. Labels in the sense they can provide some guidance. Labels can provide guidance, right? So that process is called supervised learning. If at all there are no labels provided in the data set, then that process of grouping the instances, grouping the elements is called as unsupervised learning. And that is just remember and leave the concept. That is not that is somewhat side track actually. But those are also some important points under the classification. And coming to the second phase, testing phase. So here a test set which is generated randomly from the data set. We already know that both training and testing sets are generated randomly. So 70% of the data is generated. 70 is to 30 is approximate ratio, I'm telling you. Somebody may take 60 to 40 or 70 to 30, 80 to 20, they may vary. But obviously, train set size should be greater than the test set size. So here a test set which is generated randomly from the data set other than training set. Note this point. So there should not be any common tuple between the training and testing data. So we have different training and testing sets. There should not at least one common tuple or one common observation for training and testing sets. So it is used to estimate the predictive accuracy of the classifier as said by the number 37, I think. So as said by number 37, what is the purpose of test data? It is used to test the accuracy because if at all there is no test data, we can't able to test the model. Thereby, you can't able to conclude that whether the model is efficient or not. So if the accuracy of the classifier is considered acceptable, the classifier can be used to classify future data tuples for which the class label is not known. So if at all, this is a test environment. This is a test environment. If at all it is successful, then the same model can be used to classify the actual test environment. So if the accuracy of the classifier is considered acceptable, that means if at all the model is acceptable, if at all the model performance is good, the classifier can be used to classify future data tuples. Some unknown tuples also it can be able to classify. Again, I'm going to this, going to have some examples. If at all, if your model on the train set, you have constructed some model on the train set and you have tested the model on the test set and it gives the good accuracy. 100% accuracy is may not be possible for any kind of classifier. No classifier provide 100% accuracy. So you can get the maximum accuracy as 99, 98, 97 like that only. Depends upon your data set. If at all, if suppose you have generated a model and that model performance is good as tested with this test set, if at all the model is good, you can able to use the same model to classify the new observation or unknown observation. How? If suppose this is my unknown observation, here I am having a sepal length in the top of the data set. I am writing the new observation. Here my sepal length is 5. Here my sepal width is some 2.3. Here my petal length is some 3.3. And here petal width is some 1.3. For example, petal width is some 1.3. This is my observation. So based on this training data, since this classifier, some X is there, since here the model name is X or here classifier name is X, and it is proved that it is successfully, that means it is efficient in classifying the test data. So I can assume that since it is efficient in classifying the test data, it can also efficiently can classify the unknown example. So this is my unknown observation. This is my unknown observation. So what is the class label? This observation is not present in the data set. You can check. So this observation is not present in the data set. This is a completely new observation. So I can able to predict the class label based on this model, based on this constructed model. So what is the class label? So based on its training experience, it can assign one of the label like versicolor, suppose. Why versicolor? Because if you observe, most of the versicolors consisting of 5 here, 2.3 here, 3.3 here, and here some little change also. Because the data is completely new, right? So it compares the new observation with existing ones, and it has some internal calculations based on the classifier we have used. If you use the KNN classifier, it performs in particular way, one way. If you use the decision tree, it go in another way. Each classifier has its own way to classify the new observation. It has its own formula inside. So it is already implemented and the model is already constructed. The simple thing is only what you need is you just submit the new observation to the classifier. So here is the constructed model, and here you are going to check the accuracy of the model. If at all the model's accuracy is good, what I can do? I can submit the new data. Again here I can submit the new data to the classifier and it can able to results. But there is no way to check whether the results are accurate or not, because these are really unknown observations, because the real time observations these are. So it generates some labels. And the best example here is some artificial diagnosis, uh, human health diagnosis system, if you consider that. So if at all some robot is there and you need to enter your disease feature, so having some cough, so it asks you something. You are having some cough, yes. You are having some headache, no. You are having little fever? Yes. Your temperature is 100? No. So like that, it asks you some questions. And based on that question, it generates some label. What's the label? You are having so and so some what ఏదో disease ఉంటుంది కదా nose సంబంధించి pneumonia for example. So if you are having pneumonia, if you are having so and so feature, you just simply enter all the answers posed by the robot or expert system or whatever artificial expert system is there. So you are simply need to answer the questions posed by the robot. So it finally displays the disease. You are having that or not. So most probably, it accurately identifies your disease. Some cases it may go wrong. That's why I'm telling no classifier is accurately classify 100% of all the things. So what is there in an artificial robot? There is a classification algorithm. So everywhere, wherever you go, you find the machine learning application. So in the robot, there is a classification algorithm, and it takes all the characteristics of the disease. Just like what are the characteristics of the flower here? Sepal length 5, sepal width 2, petal length 3.5, petal width 1. All these are the characteristics. If you are inputting something, it generates some output based on the model constructed. So the classifier model is constructed, and it is inculcated in artificial expert system. And by executing that model, it can able to answer you. So most probably, it may up to the mark, it may tell correct answer. It may give correct answer. Correct answer in the sense correct disease. It can able to properly identify the disease. But there is some cases where it can wrongly identify the disease. Even though all the features of pneumonia are there for a person, he may not be attacked with pneumonia. So sometimes it may go wrong. So how to make that mission? How to increase the perfection of the mission? By initially testing with the test data like this. By initially testing with the test data, if at all it is getting perfection with the test set, then only you can allow that model to classify the real life examples or unknown examples or future observation. That is what here. So if the accuracy of the classifier is considered acceptable, the classifier can be used to classify future data tuples for which the class label is not known. And here we are having two types of classification, binary classification and multi-class classification. So coming to the binary classification, I think it is already familiar. You know that what is meant by binary dataset and binary class dataset and multi-class dataset. So if the classifier task is to classify the observation among the two labels. So if at all there is only two labels, then it is a binary class classification. Binary, not binary classification, it is binary class. Binary class classification. So the process of classifying the observations into either of two classes. So whereas here, multi-class classification. This is the process of classifying the observation into multiple classes. So we are already familiar with this, right? And coming to the process of prediction. What is meant by prediction? What is the major difference between the classification and prediction?
Madam.
Yeah.
Manas ma'am.
చెప్పండి
11.
ఆపేస్తాను.
అది మన నెక్స్ట్ క్లాస్ కి మళ్ళీ జాయిన్ అవ్వాలి కదా మేడం.